Okay, recording again. So recording. Share the screen. All right, we're good, I think. All right, so we have to make up for some lost time, but it shouldn't be that bad. I wasn't going to take the entire class period anyway. I don't think I need to. Okay, so here we are, 13.1, which is on polynomial long division, which is something you've seen before. So today we're doing polynomial long division. But we're also doing something which may be new, but some of you may have seen it before, synthetic division. Okay, so if you've already heard of synthetic division, there's nothing new today. Polynomial long division should not be new to anybody, but synthetic division may be. Okay, so that's what we're doing now. So let me mark off where we are. We are right here. So 13.1. So 1 to 17 is on polynomial long division. 2139 is on synthetic division. Okay. So I think we're good now. So let's go ahead and try to get started. 13.1, page 925. Okay, long division, 1 through 17. For those of you that don't have the book and aren't getting it. So there's 1 to 13 odd, 15 and 17. And then synthetic division, 21, 23, 25. And you had to go up to 39, it looks like. There we are. Okay. Okay, so here we go. Polynomial long division. So this should be just for a refresher. This should not be brand new. And I'm going to lecture assuming you've seen it before. Okay, so number 1, x squared minus 8x plus 4 divided by x minus 3. Okay, we'll set up long division just like long division of numbers. Inside is going to be the x squared minus 8x plus 4. Outside is x minus 3. So it goes like this. X squared minus 8x plus 4. 1. Right? Remember doing this before in algebra? So number 1, x squared minus 8x plus 4, that goes on the inside. And x minus 3 is on the outside. Okay, so you take the first thing here and the first thing here, and you ask yourself, what do you multiply this by to get this? So how do you go from x to x squared? Well, you have to multiply by x. Okay, so put x. Now I'm going to line up the x with the x column. This column is dedicated for x's. Numbers, x is x squared. Okay, now what do I multiply x by to get all this? So in other words, I go x times this whole thing. X times x is x squared. X times a negative 3 is a negative 3x. And then I subtract, just like long division of numbers, right? You subtract. Now, when you subtract, you have to be careful of all the double negatives and such. X squared minus x squared is nothing. Negative 8 minus a minus 3, that's negative 8 plus 3, which is negative 5x. And then I bring down to plus 4. Right? Very much similar to what you did in long division of numbers. Okay. And then I do it all over again. So first thing here, first thing here. What do you multiply x by to get negative 5x? Negative 5. So negative 5. Now I'll take negative 5 times this whole thing. Negative 5 times x is negative 5x. Negative 5 times negative 3 is a positive 15. Subtract. Yeah, this negative is all over, but this cancels out, doesn't it? It's negative 5x minus a minus or plus 5x, so that's gone. 4 minus 15 is a negative 11. This is my remainder. Okay, so how do I write my answer? And how do I want you to write the answer? Well, you have a choice. Since the remainder is negative, you can write minus remainder divided by the original divisor, like so. I'll let you do that if the remainder is negative, okay? Or you can always make it into a positive. So I'm going to change this in just a moment. So when I change it, I can't really unchange it, but maybe to emphasize that, I'll do what I normally do, switch to red, something different. Okay, since the remainder is negative, I put negative 11, the remainder over the original divisor. Okay, you can always think of it as a plus though. So if you want, you can do the following. So look at what I have here because I'm going to change it and I can't undo it. But I make this a plus and make this a negative. I'll always accept that. Okay, so if you don't want to think about anything else, for the remainder, you're always going to say, I'm going to put a plus, and then whatever the remainder happens to be, positive or negative, put that over here. So negative 11 divided by x minus 3. Okay. So this is how we're going to write it for long division. And again, this should not be new to anybody. You've all seen this before. So I'll do many more examples of long division before we do synthetic division. Okay, so that's that. So I'll just do more. About review number 5, 6x cubed minus 2x plus 3 over 2x plus 1. Okay, first thing I noticed for number 5, it goes from x cubed down to x. There's no x squared there. You might recall when you do the long division, you have to sneak in a 0x squared in there. So I'm going to write it as 6x cubed plus 0x squared minus 2x plus 3. That's the way it has to be done. 5. Oops. Six x cubed plus 0x squared minus 2x plus 3. And one more time, in the original problem, it went 6x cubed down to negative 2x. There's no x squared. You have to count it as a 0 coefficient. 6x cubed plus 0x squared minus 2x plus 3. And then it says we're dividing by 2x plus 1. Okay. All right, first thing here, 2x, 6x cubed. What do you multiply 2x by to get 6x cubed? 3x squared. Put that in an x squared column. Now multiply this times this. That times that is 6x cubed. That times 1 is 3x squared. Subtract. By the way, you will notice, even though the original didn't have any x squared column, it's sure showing up in the problem. Okay. So if you don't account for it, you wouldn't know where to put it. Okay. So as the problem develops, there's certainly a lot of x squared stuff. Okay, subtract. That minus that is nothing. 0 minus 3 is a negative 3x squared. Bring down to minus 2x and do it all over again. Okay, so how do you go from here to here? Well, it looks like I got a fraction. To go from 2 to negative 3, you have to multiply by negative 1.5 or negative 3/2. A little bit uncomfortable. And an x. So negative 3/2 times 2 is a negative 3, so that works. Okay, now I take this times this whole thing. So negative 3/2 x times 2x is a negative 3x squared. And negative 3/2 x times 1 is negative 3/2 x. Subtract. This cancels out. Negative 2 plus 3/2. It's negative 1/2. So negative 1/2 x, bring down to plus 3. Negative 2 plus 1.5 is negative 1/2. Okay, what do you multiply 2 by to get negative 1/2? 2 times what number is negative 1/2? It's negative 1/4. Negative 1/4. 2 times negative 1/4 is negative 1/2. Okay, now negative 1/4 times this whole thing. Negative 1/4 times 2x is negative 1/2 x. Negative 1/4 times 1 is negative 1/4. Subtract. This cancels out. 3 minus a minus 3 plus 1/4. 3 1/4. 3 1/4 or 13/4. 13/4 is my remainder. Plus 13/4 divided by 2x plus 1. So definitely a lot more clumsy because of the fractions, but it can still be done. Okay. All right, so that's that one. All right, let me show you a more extreme case where stuff is missing. Number 9. X to the 6 minus 64. Once you have x to the 6, you have to have x to the 5th, 4th, 3rd, squared, and x. And if they're not there, count them as a coefficient of 1. So even though it says x to the 6 minus 64, I must go like this. X to the 6 minus 64. Question 9. X to the 6th, 0x to the 5th, plus 0x to the 4th. They all got to be there. So 0x cubed plus 0x squared plus 0x, and finally minus 64. It has to be done that way. And you're dividing by x minus 2. Now, at the beginning of the problem, you don't see all this stuff, right? All this stuff isn't there. It goes straight from x to the 6th to minus 64. So why do we need to put all this? As the problem develops, as we work the problem out, you will see x to the 5th, 4th, 3rd, squared x. They're all going to appear. So we need to dedicate space to it, as we shall see. Okay. X to the 6th. What do you multiply x by to get x to the 6th? X to the 5th. Put it in x to the 5th column, and there it is. I got a column dedicated for x to the 5th. Now go x to the 5th times this whole thing. X to the 6th minus 2x to the 5th. Subtract. That cancels out. 0 minus a minus 2 is a positive 2. Bring down to 0x to the 4th. Now you might say, do I have to bring down to 0x to the 4th? Again, think by analogy when you're doing long division of numbers. When you did long division of numbers, if there was a 0, you brought it down, right? So same thing here. It's a 0, just bring it down and you'll see that it works. Okay, how do I go from here to here? X, 2x to the 5th, 2x to the 4th. All right, 2x to the 4th times this whole thing. 2x to the 5th minus 4x to the 4th. Subtract. Cancel. 0 minus a minus 4, positive 4x to the 4th. Bring down to 0x cubed. Do it again. First thing here, first thing here. How do you go from x to 4x to the 4th? 4x cubed. Now 4x cubed times this whole thing, 4x to the 4th minus 8x cubed Notice all the columns are nice and lined up. Everything here is x to the 6th. Everything here is x to the 5th. Everything here is x to the 4th. Everything here is x cubed. Okay, that's the reason why you dedicate space to it. Even though I went from x to the 6th to negative 64, you got to have 0x to the 5th, 0x to the 4th, 3rd, squared, x, all the way down the line. Okay, 4x to the 4th minus 4x to the 4th is nothing. 0 minus a minus 8 is positive 8x cubed. Bring down to 0x squared. Just keep going. First thing here. How do you go from there to there? 8x squared. Now 8x squared times this whole thing. 8x cubed. 8x squared times negative 2. Negative 16x squared. Subtract. This cancels out. 0 minus a minus 16, positive 16x squared. Keep going until you run out. I'll be running out when I get to 64. So bring down to 0x. Now it's almost to the point where I can't show you both at the same time. X, 16x squared. How do you go from x to 16x squared multiplied by 16x? Now 16x times all this, 16x squared minus 32x. Subtract. Cancels. 0 minus a minus 32x. 32x. Bring down to minus 64. Okay, please notice everything's lined up. X to the 6th, x to the 5th, x to the 4th, straight down. X cubed, x squared, all the way down. All the x's line up. And then the numbers. Okay. How do you go from x to 32x? 32. Now 32 times that whole thing is 32x minus 64. Perfect, no remainder. So there's no remainder. I don't have to put this plus or minus anything. That's it. So that's my answer. So you can see it's a much longer problem because of how long it started off with x to the 6th, but it's all there. Okay. Okay, 13. Three y cubed minus 4y squared minus 3 divided by y squared plus 5y plus 2. Okay, the bottom's okay. The top is not quite okay. Look at the top for 13. It goes y cubed, y squared. There isn't a y. Count it as a 0y. Right? 3y cubed minus 4y squared plus 0y minus 3. Right? One more time, the original problem did not have a y for number 13, so you count it as a 0y and then the minus 3. Then everything else is the same. Y squared plus 5y plus 2. Okay, first thing here. How do you go from y squared to 3y cubed multiplied by 3y? Line that up in the y column, which you would not have had if you went straight from 3y cubed minus 4y squared to the minus 3. Then you wouldn't have any place to put this. But since I put the 0y, now there's a space for it. Okay, now 3y times this whole thing. 3y cubed. 3y times 5y. 15y squared. 3y times 2, 6y. Subtract. Cancels out. This first thing's always going to cancel out if you do it the right way. Negative 4 minus 15 is a negative 19. 0 minus 6 minus 6y minus 3. Do it again. What do you multiply y squared by to get negative 19y squared? Negative 19. Now, negative 19 times all this. Negative 19 times y squared. Negative 19y squared. Negative 19 times 5 is negative 95y. Pretty bad numbers here. Negative 19 times 2 is a negative 38. Subtract. Cancel, cancel. A lot of double negatives here. Negative 6 plus 95. Double negative, right? 89. Negative 3 minus a minus 38. Negative 3 plus 38. 35. That's my remainder. So plus remainder. Over divisor. And there we go. Okay. Okay, so I think I'll just show you one more of that type. 15. And then I'll get started with synthetic division. T to the fourth minus 4t cubed plus 4t squared. Aha, there's no t term. So put 0t minus 16 divided by blah, 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 blah. Okay. Let's try that. T cubed minus 4. Oops. T to the fourth, sorry. T to the fourth minus 4t cubed plus 4t squared. There's no t, so count it as a 0t minus 16. T squared minus 2t plus 4. T squared minus 2t plus 4. Okay, then I think we're good. All right, how do I go from here to here? T squared to t to the fourth, t squared. Now t squared times that whole thing, t squared times t squared. T squared times negative 2t is a negative 2t cubed. T squared times 4 is 4t squared. Subtract. This cancels out. This cancels out. Negative 4 minus a minus 2 is negative 4 plus 2. Negative 2t cubed plus 0t squared plus 0t. A lot of zeros, but that's okay. Remember that. Start again. How do I go from t squared to negative 2t cubed? Negative 2t. Negative 2t times all that stuff. Negative 2t cubed plus 4t squared minus 8t. Subtract. Kind of painting myself into a corner. Barely have enough space. See if I can squeeze it in. That's gone. Negative 4t squared. 0 minus minus 8 is plus 8t. Bring down to negative 16. And one more time. How do you go from t squared to negative 4t squared? Well, negative 4. So -4 times all that, -4t squared. Fortunately, I'm just barely going to make it. Then -2t times -2t, sorry, -4 times -2t is +8t. And -4 times 4 is -16. And I don't have room to put a remainder, but fortunately there is no remainder. So I just barely squeeze it in. So I have my answer. So there it is, no remainder. All right, so that was polynomial long division. Let me do the focusing thing again. But again, this should be old hat for you. You've seen this before. I'm guessing in at least 2 algebra courses. You should have seen it in Algebra 1 and Algebra 2, or elementary and intermediate algebra. Okay, so the rest of the problems, we're doing something called synthetic division. Okay, so what is synthetic division? Okay, so what time is it? I'll introduce it, do some problems before the break, and then some after the break. Synthetic division. The first thing I'm going to say about synthetic division is it only works when dividing by a linear expression. And furthermore, with coefficient 1, i.e. like x minus a. So if I'm dividing by x minus a, I can do it. So it only works when dividing by a linear expression with a coefficient 1. So I could do it here, x minus 3. Here I can't quite do it. Coefficient is 2 before the x. So I can't do it here. This one I can do it, x minus 2. This one I cannot do it. It's not linear, there's a squared. This one I cannot do it. Right? So it only works when I'm dividing by something like x minus a. So if you just casually look at the problems, I got 21 divided by x minus 5, I can do it. 23, x plus 1, I can do it. 25, x minus 4, I can do it. Okay. 27 divided by x minus 2, 29, x plus 2, 31, x plus 4, 33, x minus 10, and so on. Okay. Then we're allowed to do it. Even something bad looking like 37, you can do it. X minus 2/3. It does look in the form that I want. Okay. All right, so by way of introduction, let me do one by long division and then show you the synthetic division. So 21, synthetic division. X squared minus 6x minus 2 divided by x minus 5. So first I'm going to do it the way that we're used to. Okay. Let's do it like we're used to. What do you multiply x by to get x squared? X. Now take x times this whole thing. X times x, x squared. X times -5, -5x. Subtract. X squared minus x squared is nothing. -6x minus a minus 5, so -6x plus 5x is a -x. Bring down to -2. Do it again. What do you multiply x by to get -x? -1. -1 times this whole thing. Negative 1 times x is negative x. Negative 1 times negative 5 is a positive 5. Subtract. Negative x plus x cancels. Negative 2 minus 5 is negative 7. The remainder is negative 7. You could write minus 7 over x minus 5. I will always accept that. But if you just want to think, I'm always going to put a plus and then put the remainder. Okay, so plus negative. That's always going to be acceptable to me also. Okay. Now, synthetic division. Synthetic division. You notice it can get really long. I mean, look at how long all of this writing was, right? X to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, super long, right? Suppose back here, I didn't write the x to the 5th, 4th, 3rd, squared, x. Okay. If I just say, okay, I don't feel like writing the x to the 5th, 4, 3, squared, x. I just wrote 1, 2, 4, 8, 16, 32 with the understanding that that means 1, that means x squared, x cubed, x to the 4th, x. I didn't lose any information, right? Say everything here is x to the 5th, everything here is x to the 4th, x cubed. I'm just not going to write it. We understand it. So suppose I just put 1, 2, 4, 8, 16, 32, and don't leave any numbers out. If anything's left out, count as a 0. We could agree to say, okay, this always means 1's, x squared, x cubed, x to the 4th, x to the 5th. I'm not going to put it. Okay. Furthermore, notice it was clumsy by doing all the subtraction, right? Subtract, subtract, subtract. Got a little bit clumsy. You have to watch out for double negatives. Subtract. Okay. Well, when you subtract, you add the opposite, don't you? Right? Subtraction is the same as adding opposite. So if I say subtract 7, you could say add negative 7. What that means is this. What I'm going to do here. I'm just going to x squared minus 6x minus 2. See that? That represents x squared minus 6x minus 2. If we know what we're talking about, that's the units, that's the x squared. Okay, then I see a negative 5 here, but I'm going to write a positive 5. Bracket it off like that. Which means ignore the x, it's always there. Remember, it's only for linear expressions. Linear expressions means x minus a or x plus a. Ignore the x, it's always there. Change the sign of this. So if this had been a positive 5, I would put a negative 5. If this had, it's a negative 5, I put a positive 5. Okay. Now watch what happens. Bring this 1 down. Multiply. 5 times 1 is 5. And instead of subtracting, add. Add. What's negative 6 plus 5? Negative 1. Do it again. Multiply. 5 times negative 1. Negative 5. Add. Negative 7. Okay. So bring this down. Multiply, add, multiply, add. So it goes 5 times 1 is 5. Add instead of subtract, because I'm adding the opposite. Negative 6 minus 5. Negative 6 plus 5 is negative 1. 5 times negative 1 is negative 5. Negative 2 and a negative 5 makes negative 7. 1, negative 1, 7. 1, negative 1, remainder is negative 7. The way I read this now that I'm finished is it's x minus 1 plus negative 7 over the divisor. I get the exact same information, but look at how much more compact this is. Much less writing. Okay. I didn't have to write all the x's and x squared and x cubed or whatever. I just know this is units, x's, x squared, and so on. Instead of subtracting and getting double negatives, I add the opposite. Right? So once I see this 1, negative 1, negative 7, 1, negative 1, negative 7, it now means x minus 1 plus negative 7 over x minus 5. So that's the way it works. Okay, so it's about our break time. So we'll break until 12:10 as usual. After the break, I'll show you some more of of this synthetic division. Okay. Anybody join late, go ahead and put it in the chat, so I'll get you for attendance later. Okay, so break time until our usual 12:10. Okay, folks, let's try to pick up where we were. Let's see, Cecil, I got you, and Victor, I got you. All right, so I'm going to do some more synthetic division, and then that'll be it for today. Okay, so let's pick up where we were. Just going to get back, sharing the screen. Okay, so synthetic division. Okay, so 25, 6x to the third minus 5x squared plus 2x plus 1 divided by x minus 4. I'll write the whole problem out this time, but I may not be willing to do it too many other times. Plus 1 over x minus 4. Double check there. 6x cubed minus 5x squared plus 2x plus 1 divided by x minus 4. Okay, you will see how much nicer synthetic division is. You don't have to write all of this. Look at how much extra writing there is, right? Look at all the x to the 6th, 5th, 4th, 3rd. We just say, okay, everything's lined up, right? If we keep everything lined up, we know this means numbers, x squared, x cubed, x to the 4th, x to the 5th, x to the, we're just not going to write it until the very end. Save a lot of space, save a lot of writing, okay? And again, instead of subtracting, we will add the opposite. Okay, so over here, I don't put -4, I put 4. So I box off the 4. And across the top, let's see, am I missing any terms? X cubed, x squared, x, and number. No, everything's there. Okay, so 6, -5, 2, 1. This represents the same thing as 1, 2x, -5x squared, 6x cubed. We're just not writing it. We understand that's what it means. Draw the line. Okay, now this first number comes straight down always. So 6 drops down. Okay, now we multiply and add, multiply and add, multiply and add, and so on. 6 times 4, 24. Add 19. Keep going. Multiply. 19 times 4, 76. Add 78. You say, I thought we were supposed to subtract. Ah, we're adding the opposite. That's the reason why we're changing the sign, right? Remember back here before the break, right? We're doing all the subtracting and double negatives. Man, that's kind of clumsy. And say, hey, why don't we just add the opposite? And you'll get the same answer. Okay, multiply and add. Well, that's a little bit clumsy. So what is that? 312, I think. 8 times 4 is 32. 312. 313. Right. How do I read my answer? 6x squared plus 19x plus 78 plus 313 divided by x minus 4. But look at how much less writing there is. Okay, you can convince yourself if you went ahead and did this long division, you'll get the exact same answer. Right? Instead of writing all that x squared, x cubed, we just say, okay, I know it's there. We just won't write it until the end, and that's going to be my remainder. Okay, so it's much, much faster, as you can see. Now, stuff like 27 and 29. I'll do 29. X to the 5th minus 1 divided by x plus 2. So I know I got to have x to the 5th, x to the 4th, 0, x cubed, 0, x squared, 0, x, 0, and finally -1. So this is -1, no x's, no x squared, no x cubed, no x to the 4th, x to the 5th. Okay, then follow the pattern of what I did over here. X plus 2 means what number do I put over here? Not quite 2, -2. You change the sign. Okay, another nice thing about doing this long division, see how long this was? You kind of shove everything up, just push everything up to one line. You'll see you get the same answer. Okay, multiply, add. Keep doing it. Multiply, -2 times -2. Add. multiply, add, multiply, add, multiply, draw a line, add. Much less writing, much more compact. Now, if I wrote it by long division, this thing would probably be as long as this. Come all the way down, blah, blah, blah. You get the same answer. So how do I read this? Now, this used to be x to the fifth. It's always going to go down by 1 power. So this would be x to the fourth, third, second, first number. So final answer, x to the fourth minus 2x cubed plus 4x squared minus 8x plus 16. And the remainder is negative 33. So either minus 33 over the original divisor x plus 2. So again, you can either write it like that or in red, go like that. I'll accept either way. Okay, so this is synthetic division. Much nicer. But again, it only works if you're dividing by a linear expression with a coefficient of 1, like x minus a or x plus a. So x plus 7, x minus 3, something like that. Okay. $31. Is anything missing? X to the fourth, 6x minus 6x cubed. There's no x squared, so that's a 0. There's no x, so that's a 0. And then 2. Okay. So x to the fourth, that's like 1x to the fourth, minus 6x cubed. Number 31, x to the fourth minus 6x squared, x cubed, 0x squared, 0x, and then a 2. Like that. X to the fourth minus 6x cubed, and then it just says plus 2. That's 0x squared, 0x, and 2. 31, dividing by x plus 4. So what number do I put in the left? It isn't 4. It's negative 4. Okay. By the way, it's always going to be like this. You're always going to draw the little line here. This would be the remainder. This would be the quotient. This comes down. Multiply. Add. See, much more compact when I'm not writing all the x squareds and x cubed and x to the fourth and all that stuff. Okay, multiply. 40. Add. Multiply. Add. Multiply. Negative 4 times negative 160 is positive 640. Add 642. Quotient, remainder. I started off with x to the fourth. This is now x cubed. X cubed, squared, x number. So my answer is x cubed minus 10x squared plus 40x minus 160 plus 642 divided by x plus 4. See how it works? Again, look at how nice and compact everything is. So your expression will always get knocked down by 1 exponent. So if it used to be x to the fourth, it's now x cubed. If it started off with x to the fifth, it'll go down to x to the fourth and so on. Okay. $35. X cubed minus x squared. What's missing? X and a number. So I'm going to put 1, negative 1, 0, 0. Right? 0x plus 0. So 1, negative 1, 0, 0 for number 35. x cubed minus x squared, and that's all they said. So plus no x plus nothing. Okay, and number 35, I'm dividing by x plus 5. Therefore, what do I put on the left side? Negative 5. Bring it down. Multiply, add, multiply, add, multiply, add. Multiply, negative 5 times 1. Add. Multiply, negative 5 times negative 6 is 30. Add 30. Multiply, negative 150. Add negative 150. Quotient, remainder. 1's x is x squared. So x squared minus 6x plus 30 minus 150 divided by the original x plus 5. Okay. That's synthetic division. So whenever we get the chance for the future problems, we're going to do synthetic division because frankly, long division gets long. Long division is long, kind of obvious, but we'll do the synthetic division whenever possible. Okay, I'm almost done, folks. 37, there's a couple of things wrong with 37. Look at the numerator. It's out of order, right? So since it's out of order, I'm going to put the 54x cubed first, and then the negative 27x squared, and then the minus 27x, and then the 14. So if something's out of order, put it in order. And I'm stuck with a fraction x minus 2/3, which means I put a positive 2/3 on the far left there. Okay, so 2/3. And then 54, negative 27, another negative 27, 14. Okay, again, I'm putting it in the right order. 54x cubed comes first, then negative 27x squared, another negative 27x, and then 14. So 54, negative 27, negative 27, 14. Okay. 4. Multiply. 2/3 times 54. You can punch it in your calculator. Comes out to be 36. Add. Multiply. 2/3 of 9 is 6. Add negative 21. Multiply. 2/3 times negative 21. Negative 14. Add 0. No remainder. 54x squared plus 9x minus 21. That's it. $39 is the last one, and I'm done, folks. So I'll be done in a few minutes. If anybody has any questions, be ready to bring them up. Otherwise, we're finished. 39, x to the 4th plus 3x squared plus 12. So what's missing? There's no x cubed, count as a 0. There's no x, count as a 0. So I'm going to write 1, 0, 3, 0, 12, right? 1 for x to the 4th, 0 for x cubed, 3 for x squared, 0 for x, and then 12. Okay. 1, 0, 3, 0, 12. And for 39, I'm dividing by x minus 3. So on the outside, I don't put a negative 3, I put 3. And there we go. 1. Multiply. Add. Multiply. Add. Multiply. 3 times 12. Add. multiply 3 times 36, punch it in your calculator, 108, add 120, quotient, remainder. X to the 0, 1, 2, 3, x cubed. And furthermore, we started with x to the fourth. We always go down by 1. So if it starts off with x to the fourth, synthetic division will bring it down to x cubed. So the answer, x cubed. Now in my final answer, if there's a coefficient of 0, you don't write it. X cubed, 0x squared plus x. Looking at x cubed plus 3x squared plus 12x plus 36. Remainder over divisor, 120 over x minus 3. Okay, and I'm done, folks. So I'll do my focus thing. So even though I lost the first 10 minutes due to issues of connection, we're still okay time-wise. Okay, so I'll do my focus job here. If anybody has any questions, you can put it in the chat now or get ready to mute yourself. Otherwise, we're finished. All this. And all this. All right. And we're done. So schedule-wise, somewhat on par. Okay, so 13.1. Tomorrow, 13.2. I don't have to finish 13.2. I can still use some of Thursday. It's a little bit longer section. So I might use some of Thursday and then for the quiz for that. And then we're still going to be okay time-wise. Okay. All right. Any questions, please? We'll check the chat and see. Okay. Anybody else? Question? All right. I don't see or hear anything. So we're done for the day, folks. All right. So have a good afternoon and we'll see everybody tomorrow. Okay. All right. Bye, everybody.